This is The Data Slice, hosted by the Data Science Alliance. It's where we sit down to talk all things data science, AI, and tech, any way you slice it. I'm Callan Hoffman, and joining us today is Tony Reina. He is the head of machine learning at Exthymic, which is a biotech company here in San Diego. But Tony, you've also done a lot of things. You are a principal data scientist at National Resilience. You have been the chief AI architect at Intel. Also a stay-at-home dad for 12 years, which is a story in itself that I'm sure you'll share with us. But you've done a lot in the industry with data and AI, so we're really excited to have you on the podcast. How are you doing today?
I'm doing great, Callan. How are you?
Very, very good. We're really excited. You're also very involved with the Data Science Alliance. You've really helped us with our framework for responsible data science. You're a working group member, a volunteer.
Yeah.
So we appreciate you letting us drag you onto our podcast as well. So I was thinking maybe before we dive into a little more about your job and your career, could you maybe just give us a little more background? Where did your interests start? What was your kind of education and career path to where you are now?
Yeah, absolutely. So when I was a kid, like many of the kids in my neighborhood, we liked the Bionic Man, the $6 million man. And so we wanted to make bionic prosthetic people. And so for my undergraduate, I did biomedical engineering, and I then went to medical school, and I was starting an internship in internal medicine, and I didn't like clinical medicine as much as I thought I would. So I was lucky that I had a boss from NIH. I'd been doing research there in undergraduate and in medical school. And I called him up and said, hey, I think I'm going to be going into basic research again. And he says, oh, this is great. There's this guy out where are you at right now? I said, I'm in San Diego. He says, there's this guy out there. I'll get you a postdoc. And so I did a neuroscience postdoc for 5 years. My wife is a psychiatrist, and she went through the Navy. And so she had 12 years to pay back, which ended up being 25 years. So she retired from the Navy a few years ago. It was only supposed to be, when we decided to have kids, that's when I started to stay home, and we decided, hey, let's go to Sicily because we'll need to do for the Navy an overseas kind of tour. And so we had kids, and it was only supposed to be maybe 3 or 4 years that I'd stay at home and then, have daycare or something and get back into the full time. Life got in the way, and so 12 years later, I finally went back full time. When I went back, I ended up doing a master's in data science at UCSD. And that was great because it allowed me to get into the internship program at Intel. And from there, I moved to National Resilience, which is a biotech company here in San Diego. And then I got poached there from back in April by an old friend. And so I'm in a small biotech startup, just 14 people, called Exthymic now.
I feel like your story is a great example of how you never necessarily know, what could happen, but you've kind of done it all. You've done the parenting, the corporate, and now startups. So you've kind of experienced everything,
That's
really,
right.
in many ways.
Yeah.
I wanted to ask about, I know that along that journey that you just described, you patented a telemedicine device. Could you talk a little about that?
Yeah, so that one was a really fun project. The story around that one was there was a friend of ours who was actually the guy who introduced my wife and I in college. He also was a biomedical engineer, and he also went to medical school, and he became a urologist in the Navy. And so he was here at San Diego at Balboa, and he found out I was back in the area, and he did a lot of Da Vinci robotic surgery for urology. And he said, hey, I got this great idea for telestration for robotic surgery. And he told me about it. And, from your background, you've done telestration where you've done annotation tools, and you can scribble and do circles and highlight things and do arrows and things like that. But for surgeons, they really want to see the tools. They want to see how the tools move. They want to get a sense of how fast and how hard and how soft and that sort of thing. What we ended up doing was coming up with a telestration tool that had a three-dimensional realistic view of the tools that were being used by the robot. And we had joysticks that they could move around and have the tools move in the natural manner. And what was unique about it was we took the video image that was coming from the robot, that this is what the surgeon would see, and we overlaid that on a physics mesh. And the physics mesh had the properties of skin or tissue. So you could actually pull or cut or retract or twist or suture the video screen. And so it was really great because one surgeon could literally show not just where they were going to cut, but how they were going to cut, how fast, how they were going to retract. And you could actually see the skin or the tissue retracting. So ended up patenting that. And we had a friend, one of his friends has a telemedicine company. So we partnered with them for it.
Wow.
Yeah.
How does that feel to know that you created such a, helpful device for surgery that can really make a difference for people?
Oh no, it was amazing. And it was one of those things where I was like, that probably should exist, but I couldn't find it.
I guess I'll make it.
I guess I'll make it. And it happened to be the reason one of the reasons he got to me was he knew that I was staying home. And so he said, hey, do you think you could spend some nights doing this? So it ended up being more than just a few nights, but I would take care of the kids during the daytime, and this is what I would do many nights.
And now you are the head of machine learning at Exthymic. Could you tell us a little more about what Exthymic is and what you do?
Yeah, absolutely. So Exthymic is involved in cell therapy, which is a new type of medicine, essentially. It's primarily right now for treating blood cancers, but it can be applied to all sorts of cancers. The idea is it's one of these personalized medicines where, let's say, God forbid you had cancer, we would actually take your blood and we would put it on our device, and our device would then go through your blood for the immune cells that would help to fight your cancer. And so we would train them up and teach them in a instrument how to fight your cancer, and then we would give you that back as a drug. And so your own immune system would be fighting your cancer.
How does it feel to be a part of something like that that can, literally help people with cancer, which is such a horrible disease, and you're making a difference for those people?
Yeah, absolutely. And the big thing about this one, and this is really the reason that we exist, is this technology, this therapy exists. But of all the companies that are out there doing it, it's really hard to scale and it's really expensive. Mm-hmm. And you can kind of understand the way I was describing it. I can't make the drug until you give me your blood. It's not like penicillin, and I can make millions of doses, and whenever you need it, I'll give you one of your doses. So the clock goes, the second I draw blood from your vein, the clock is going for me to make this thing. Mm-hmm. And it's a very complex process. It takes PhDs to do. So right now, of all the companies that are doing it, they can probably get around 10,000. That's what I've seen in the literature, about 10,000 total doses per year, at a cost of $500,000 to $1 million per dose. Sure. So it's way expensive, and there's really not enough of it around to really make a profound impact. What we're hoping to do is to make it highly available at a low cost by allowing this instrument to optimize and hopefully modernize a lot of the processes. Mm-hmm.
Much more accessible, lower barrier to that treatment.
Yeah. I mean, I don't want. This is one of those things that people have actually used the term cure with this type of therapy, and it shouldn't just be for a few people who are very lucky and very rich. It should be available to everyone.
Yeah. How have AI and data helped with the work that you're doing?
Yeah, so primarily the work that I do day to day is with taking a look at those cells in microscope images, and it's moving through fluids. And so I'm using computer vision, which nowadays convolutional neural networks are kind of the workhorse of a lot of the computer vision that we do, at least at Exthymic. As it's evolved, AI in the last few years has had this transformation of things called large language models and graph neural networks. and diffusion neural networks as well. But we're primarily using the LLMs, the large language models, things like AlphaFold, to help us to create the proteins, particularly the antibodies that we need to go into the instrument. And so some people might not realize, but in addition to like the cell therapy, there are also therapies where you can actually make and engineer antibodies that can target whatever you want. And there are now computer models based off of AI that help you in that design.
Could you talk a little more about AlphaFold and what that does?
Yeah. So AlphaFold is a model that the kind of the holy grail. This has been since, I think it was maybe the 1960s or something like that. There was a Nobel Prize winner that said, hey, what we really need is to be able to go from essentially this long list of letters that is the building blocks, the words, the letters of what the antibody looks like, to the three-dimensional folded structure, right? So imagine having to create an origami with a piece of paper, but you don't get the instructions. Very hard to do, right? So what AlphaFold does is it's actually solved that problem. And this has been something that's been going on for a while, and there are other models, but this one did so well that people really took notice. And it was in this contest in 2020-ish, where it completely blew away the other models that had been, really good people that have been working for decades in the field, and it just knocked their socks off.
Has all of these changes and innovations kind of with the technology impacted the way FDA submissions work when it comes to drugs and treatment and all that?
Yeah, I wouldn't say anything is majorly new. When I was at Intel, our group was asked to write comments. There was a comment period for the FDA when they were coming up with the AI guidelines that they have today, and so we were one of the many companies that wrote to them and said, here's what we're thinking about it. Primarily, you're still going to have medicines that are going to go through clinical trials, that are going to go through laboratory trials. We're really talking about AI in the design process for these things. Mm-hmm. So that is that's really what has changed, is this in silico design, this in computer design has become a viable tool in the process. But at the end of the day, it still is something where you make something and you see whether that thing that you made, whether you made it from conventional means or you made it from AI, whether it actually does what you have asked it to do.
With all of that and all of this work that you've mentioned, are there any ethical considerations that you kind of need to be making? I know like we said, you're a big part of the Data Science Alliance. A big focus of ours is responsible data usage. Yeah. So are there any kind of steps or considerations that you take in your field?
Yeah, so the primary one, and I was helping with the framework here for responsible AI. I actually do I'm a guest instructor for an online course for AI leaders. And I do the responsible AI session, and I actually use the framework that we did here at DSA. And I like that it says responsible, because the thing about this is that it's actually a tangible, practical thing that we're talking about. And that's really the major thing that I stress to people, is that the FDA or any of these organizations, they're all about getting a process in place to allow for things like veracity is the big thing for us. So being able to determine where the data came from, being able to determine who changed the data, if it was changed, who pre-processed, who post-processed, where was this model from, how was it developed, what is it intended for, what is it not intended for. All of those things are actually part of a process that you'll set up with the framework. And that's really the thing that I stress, is if you can get that process in place, a lot of the other things become easier.
Do you have advice for people who are maybe newer to the industry, newer to in real world settings working with AI and data? Any advice for being responsible with that, not getting caught up in just the excitement of a new career, but really thinking about that type of thing?
Yeah. So when I talk to the people online, I talk about you've gone through ISO 9000, you've gone through Six Sigma, you've gone through some sort of process, even something like Agile. There are industry standards of how to do things and how to document things. This is akin to that. And so if you learn those things, you'll be learning this at the same time, and this will kind of help you along. The rest of it will kind of come as long as you have that mindset of we have to make sure we have really good documentation as we go along these things, and it can't be haphazard.
With the ethical considerations, but also rapidly evolving technology, are there any trends, though, that you're especially excited to be seeing, whether it's in terms of responsible data and AI or just kind of the industry in general?
Yeah, particularly with the generative AI that has been kind of blown up, if you will, in the last few years with the ChatGPTs and things like that. They're actually, and I'll talk about it in my talk today, they're actually protein versions of ChatGPT. There are many companies that are doing these sorts of AI assistants, and one of many is 310.ai, which is one that we took a look at. It's Kathy Wei's group. It's really a cool concept because it's a whole platform where you're actually, instead of having to program protein design and really, going through and understanding these very complex tools, you're actually having a conversation, a real conversation with this bot that is helping you along the way and is saying, okay, well, if you had this sequence, it should look like this. And then, okay, great. What are the liabilities of that sequence? Well, this area and this area and this area are probably going to give you problems. Maybe that's where we want to start to design around to help with those. It's a much more natural way. It's almost like having a lab assistant in the room for you.
You mentioned ChatGPT, and then you even just use the word assistant. Do you feel like AI, especially things like ChatGPT that are so accessible now, have really kind of come in as this tool and almost like partner in getting this type of work done, maybe better and faster now?
Yeah, very much so. Even in my own work, I think it's a force multiplier. So we started getting a ChatGPT license a few months ago, and I started just trying it out with the coding that I was doing for the Exthymic project. And I am serious when it's like a 10x improvement in the speed of me doing things. And it's not just that I just tell it and it just does everything. I still have to have this conversation with it. But it's great because it's a conversation with almost like a colleague that knows about as much as I do, and can really point out things that maybe I missed and says, hey, look at this thing. Oh, right, we need to change that there. What would it look like with the following 3 scenarios? And we can go through all of that in what would have taken me 30 minutes, might take me 5 minutes now. And so I can have 25 minutes for coffee. So.
It's just a little bit better each time. How does it feel to, as someone who is so experienced and been in the industry for a while, how does it feel to see that type of tech kind of becoming more and more popular and well-known, kind of seeing that just grow over the years?
Yeah. I mean, it's been amazing that I wish I would have had things like this when we were coming up. Even like something like YouTube I didn't have. And so being able to learn on your own schedule and what you want is transformational. And it's something that I didn't have the opportunity when I was growing up just because the technology wasn't there. But now you do.
Yeah. Do you have advice for people who are maybe students or earlier on in their careers that maybe aren't sure where to start, considering that there are more accessible resources now?
Yeah, the biggest thing that I tell students or people that are interested, they'll say, oh, I'm really passionate about this. I really want to do what you do. And I'm like, why aren't you? Because right now, you don't have to wait for me. I can show you 3 or 4 resources, and you can literally go out today and start using those resources, like actual coding tools, notebooks and Colab and Binder and all of these things online for free, GPU instances for free, CPU instances for free. And you can learn this on your own, or at least you can learn about this on your own. And you don't need to necessarily wait for the teacher to give you a problem set. You can start defining those problem sets. And I always want to look for that if people are applying for jobs or things like that. Mm-hmm. I always ask, where's your GitHub repo? Like, show me the things that you've done already. You know, if you haven't been curious enough to do this on your spare time, you're not curious enough to work with me to make new things.
Mm-hmm. Do you feel maybe especially optimistic about the next generation of data scientists, tech leaders, when you do see the people that are, you know, kind of taking charge, taking advantage of the resources, even when they're not in class? I know you said you used to spend your weekend nights doing this type of thing.
Absolutely.
So how does it feel to kind of see?
Yeah,
exactly. Casual hobby.
Yeah, exactly.
Does it feel good, you know, as someone older, more experienced in the industry, to see these much younger students kind of in that excitement and taking advantage of these resources?
Oh, yeah. And I mean, it's great that they have these resources and can take advantage of them. I mean, again, it'll be a force multiplier that what was, I was thinking about the kind of the hello world for a lot of AI is MNIST, the little 1, 2, 3, 4, 5 images, and using something like AlexNet. In 2012, that was a PhD level project that was better than anything else anybody had come up with in the world at that point. And now it's something quite literally that my 18-year-old could do on their laptop in an afternoon.
Wow. It's a little crazy to think, although, you know, 10 years from now, we're going to look back and say, oh, I can't believe we didn't have this.
Exactly. They'll be doing my things that I'm doing right now, and they'll be doing them. Yeah. An 18-year-old will be doing that on their laptop and for a
Do you ever get a little jealous? Maybe wish you had those resources?
It'd be fantastic, but yeah, I know it's coming, so I'm just optimistic that it's coming.
Yeah,
so.
And you made it here either way. So
and I made it here either way. So.
Are there any, I know we've kind of mentioned there are resources out there. Are there any specific ones that you would really recommend?
Yeah, so if you're going on the basic route, the one that when I was doing my internship at Intel, I spent much of the time, because my boss was like, you can do whatever you want, basically, looking at Stanford's, I think it's CS231N YouTube videos, the original ones with Andre Karpathy, Fei-Fei Li, and Justin Long. Karpathy is amazing at teaching these things, and it just seems so effortless when he teaches these things. And so any Karpathy video that you can get your hands on, he does once with LLM. He's programmed things in JavaScript for neural networks, which is like mind-boggling to do. But they were just like, when he talked about convolutional neural networks, I was like, wow, I actually understand it wasn't gobbledygook. And it was obvious that when I try to explain things, or when I explain things to myself, I'm trying to see the bits move. I'm trying to see, okay, I know it's something plus something divided by something times something. If I can get down to that level, then it's a for loop that does this, that, and the other. All of the math goes out the window at that point. I'm like, oh, I know how the bits move around, and I know exactly how that thing works at that point.
Mm-hmm. We'll definitely get those names from you, put them in our show notes so everyone can look them up. Go take advantage. Like we said, there's so much out there. So it's helpful to hear, you know, what are some of those really good ones that stand out to people like you who are, you know, people that others look up to as they begin their careers. Well, thank you so much for coming on our podcast, you know, and just talking about all of this. It's so interesting the way things are just growing and changing. Like we said, 20 years ago, we weren't here. 20 years from now, we'll be in such a different place. So we'll bring you on in 20 years, see where we're at.
Thanks, Kellen. Appreciate it.
Thank you so much. If you enjoyed this video, give it a like, subscribe to our channel, share it with a friend, and don't forget to follow the Data Science Alliance on your favorite social media platforms. We are a 501c3 nonprofit that you can support. You can do a one-time donation, you can be a monthly or annual member, you can volunteer on our projects, or come to our events. We have events every single month. We're located here in San Diego, California, and we have lots going on. So go to our website, datasciencealliance.org. That's where you can make a donation or learn about all the ways that you can get involved. Otherwise, though, we'll see you here next time on The Data Slice.